welcome back to Quick Concepts. Today we're going to be talking about volume. So again, this is more of our geometry series. You get introduced to a lot of this at the beginning of Algebra 2 in Saxon. And the reason I like that is because geometry really isn't its own separate course, because after you take that first step of knowing your formula, you're back to algebra. So I like the fact that they put this within the Algebra 2 book. So volume. Volume is essentially 3 dimensions. Think of filling up a glass. Volume, unlike area, doesn't just cover 2 dimensions, the base. It actually involves the height too. So volume is essentially the area of the base times the height. And this has to do with every shape imaginable except 3. There are 3 exceptions. Those 3 exceptions are number 1, the volume of a sphere. And the volume of a sphere is 4/3 pi r cubed. Now these are ones you want on your reference card. The volume of a pyramid or a cone, I guess we could just put those together, are going to be 1/3 pi r squared. And the reason it's 1/3, because if you think about what a cone looks like and a pyramid, I'm not even going to try to draw a pyramid. I'm terrible at drawing, so I'm not even going to try it. But is because if you think about it, you're shaving off, technically, 2/3 of it, 2/3 of a cylinder. And I think there was one more. I always want to say there's 3. Maybe there's only 2 that is separate. Sphere, cone, and pyramid. Maybe it's because I think of cone and pyramid as separate. So anyway, so these are your exceptions to this formula. So let's focus back on the original form of volume. So what are we talking about? Well, let's say we have a cylinder. And I ask you what, and let's say it's the radius is 3 and the height is 6. And I say, okay, what's the area of this cylinder? Well, you just need to know that it's the area of its base times its height. So I'm going to look at its base. The base is a circle. So this takes me down to area of a circle. And if you've already watched my area videos, you should know the area of a circle. So the area of a circle is pi r squared times your height. And then we just plug in our numbers. 3 squared times 6 is that's 9 times 6 is 54 pi. And of course you can leave it like this, or you can go ahead and multiply it out. Excuse me, this is supposed to be volume, not area. So, and again, volume is 3 dimensions. So whatever we're dealing with, like let's say this is centimeters, it's going to be centimeters cubed. So for volume, it's the area base times height. It will always be like cubic 3 dimensions. So it will be a cubic unit, whatever it is. So volume, what I like to tell people is think about filling something up. If you were talking about the volume of a cube, it's essentially side cubed, but that's the same thing as saying the area of the base times the height. So really you don't have to have a separate formula for that. So when you go to build your reference card, you can just say volume of any polygon is the area of the base times the height, except a pyramid, a cone, or a sphere. So because think about the area of a base is square of a area of the base. Let me see if I can draw this. I used to be able to draw these when I was a kid. Yeah, something like that. There's your cube, right? So it's essentially the area of the base, which would be a square, times its height, which is another side. So again, even a cube falls underneath this. Now, a lot of times you'll see something like this, and this is, I do tend to lose people on this one. They have something like this, and you know, they're like, okay, what's the volume of this? And you go ahead and write it out. You're excited, you know how to do this, and then you go, well, wait a minute, what's my base? Is my base here, or is my base here? And let me give you the definition. The base is any shape that goes all the way through. What does that mean? If I asked you, does the rectangle carry all the way through this prism, or does the triangle? I would hope to see that you would see it's the triangle that carries all the way through. So the base here would be 1/2 base times height, and let's say this is 12. The height would be 12. Okay, so let's do a couple just to practice. Let me find some good ones here. Let's see. So let's say you have something that looks like this. It says the volume of the circular cylinder, I'm going to go ahead and write this down, is 250. Now, the area of this base you can see is a circle. So I'm going to go ahead and put that in, times height. The radius they give is 5, and they don't know the height. So this one's a good one because this one is a little bit different. It says the volume of the circular cylinder is 250 pi. Now notice what I'm doing. I'm filling in, substitution-wise, what belongs where. Well, the volume was given to us. We don't have to calculate the volume on this. This time we have to calculate the height, because if you notice, we know that our radius is 5. So we're going to just do a few calculations. Let's get rid of the pi's. If we were to divide both sides by pi, they'd cancel out from both sides, and you'd be left with 250 is equal to 25 times the height. And so we can easily see that our height is going to be equal to 10. And this is going to be in centimeters. So this is a more complicated one where you're using the volume. You've got to have that formula. You've got to have that area of the base times height, but you're actually given the volume and you're working a little bit backwards. Let's see. Let's do this one. This one's a little bit difficult. These are on lesson 2 in your book. This one I just did was 7. Number 3 I'm going to do, it looks like this. This is number 3 in your Saxon Algebra 2 textbook on lesson 2. These are ones, I'm picking ones that kids usually have a lot of problems with. Okay, it says the base of a cylinder is a right triangle. Okay, now this is the base of a cylinder. That's kind of hard to deal with, but if you think about it, it doesn't really matter that it's a cylinder because we know the volume of any polygon, other than those 3 exceptions, is just the area of the base times the height. So really what I need here is the area of these 2 shapes. So then you're going to go back to your information on area. So we know the area of a sector plus the area of a triangle, and this is all times the height, which they're going to give us. So the area of a sector is our degrees over 360 times pi r squared plus the area of a triangle times height. So now we're going to just fill in our numbers as they're given. So the degree is 60, and the radius of my sector is 4. My base is 4, and my height is 7. Now this, we're going to go back to the problem, and it says, and the height of the cylinder is 8 meters. So this is going to be 1/6 pi times 16. Half of 4 is 2. 2 times 7 is 14. And this is all times 8. Now again, this is where I lose people. When you go to put this into a calculator, you're just going to just do pi times 16. And then you're going to just divide it by 6. That's what 1/6 is. It's just times 1 divided by 6. So this is going to be 8.38 plus 14 times 8. And so your total here is 179.02. And remember, again, we are dealing with meters, and it's got to be in cubes. Okay, and that is it on volume.